I've done it in the other classes. Okay, hello, welcome. We are going to do a quick review of something that you did last year. So everything we're about to do is review, but I feel like it's tricky enough and important enough that it's worth doing. So what I want to talk about is E, the Euler number. How much of this do you remember from last year?
None.
Euler.
Just kidding, some.
None, just kidding, some. Okay, so the story goes something like this. I'm going to do the sort of like, basically like traditional, what are you doing over there? I'm doing like the traditional approach. So there's this thing called money. And if you have money, for weird reasons, if you give it to the bank, and you let the bank hold on to it for a certain amount of time, then they will just like pay you more money, just to be able to hold on to your money for you. That is called interest, and that is because the bank takes your money and gambles with it while you are home sleeping, and mostly wins. All right, so how does this whole interest thing work? Well, if you have $100, let's say, and you are finding a bank which is agreeing to pay you 5% interest, and you leave the money in the bank for 1 year, then how much by that promise do we feel entitled to after 1 year is over?
How often are we compounding?
No, don't ask fancy questions. Just be like, dude, bank says I'll give you 5% interest a year, yes. $105, of course. That is implicitly what the bank is basically saying. I will give you 5% interest per year, so they're basically saying that in each year that goes by, I will give you back in interest 5% of how much you give me. Okay, so we could turn this into like formula. There is this thing called the principal, which is the amount of money that we invest in the bank. It's in dollars. There's also the interest rate, and it is important that by convention we always use a annual interest rate. So it's the amount of return we should expect in a year. And then we have the amount of time, t, and it is important that here we do this in years. Because only if we measure time in years and interest rate annually do the units match and it all makes sense. Cool? Okay, so what we learned from this simple example is that the formula, so to speak, for the amount of interest earned is going to be the principal times the interest rate times the amount of time that we leave the money in the bank. Good? Say good. Good. You could also possibly ask, hey, how much money am I going to actually have in the bank at a given time? And the answer is where you're going to have your principal, and then you're going to have plus your interest. And so the amount of money I should expect in my bank is going to be the principal plus the interest, which is the principal times the rate times the amount of time. And so if you want to, you could even write a formula that's like P times 1 plus RT. Okay, good. That is very simple, clear, straightforward, sort of boring, whatever. All right, well, it turns out that that's just like not good enough because of the following. Consider the following two scenarios. You have $100 and you would like to invest it in the bank at 6%. You found a bank which is willing to pay you 6% interest, and you are going to keep your money in the bank for 1 year. You have your $100 and you're going to save it. In 1 year's time, you're going to be 17, you're going to buy a motorcycle. All right, scenario one. Scenario one, you just go to the bank on the first day of the year, you give the bank your $100, you say, please take this, Mr. Bank, I'll be back in 1 year, and you come back in 1 year, and you say, I'd like to close my account now and give them their money back. In scenario one, how much money do we end up with at the end of the year? $106. Yep, of course. Okay. Clear as day. Well, now consider scenario two. In scenario two, you decide to pull a little tricky. Take your $100 and you invest it, at 6% interest. But now, at exactly halfway through the year, you go back into the bank. And you say, you walk in and you say, Mr. Bank, I would like to have my money back. Please close my account and give me back my cash. How much, don't overthink it, do you feel entitled to after half a year has gone by, and do you speculate that the bank would give you? $103. Okay, I agree. And in fact, if we just follow the formula, that's what it says will happen. Okay, so I take my $103 and I put it in my pocket. Then I walk out to the parking lot. I open up my trunk, and in my trunk is a duffel bag. And in the duffel bag is funny pants, silly shirts, a wig, a strange hat, mustache, googly eyes, all the things that are necessary to disguise yourself in a very inconspicuous manner. And then you walk back into the bank and you say, Mr. Bank, I am a new person, just moved to the town, and I would like to invest my $103, please, in a bank account. I have heard that you are offering 6% annual interest. Okay, and so what happens is we invest this $103 at 6% annual interest, like advertised, at 6% annual interest, and then we leave it in the bank for half a year, and then we come back at the end of the year to collect the money. How much money am I going to have?
More than $106.
More than $106.
More than $106, because it's actually tell me, give me a number. No, I think something got messed up, because now
what's 6.09?
Yeah, it's gonna be like $103 is going to be invested at 6% interest for half a year, but then we add on the 103, right? And so we're gonna earn, well anyway, the answer is, I think that's right, 106.09. Whoa, we made some serious money extra over and above by taking that little pit stop halfway through the year and withdrawing the money and reinvesting it. Can someone explain qualitatively, why? How is it that we suddenly made more money out of nowhere? Where did this extra money come from? Eli?
Because we're getting more money based on the original money we gave to the bank, so we just upped that original money halfway through, essentially.
Kind of. Someone else want to say it differently? Yeah, Winston.
So it's with your original $100, you have the 6%, and if you don't collect it over the 100 years, it's the 6% that applies to $100. While with scenario 2, it's 6% applies to $100 for half the year, but 6% applies to $103 for the other half of the year. So in the end, 103 generates more.
Yeah, Winston says, in the scenario 1, I'm earning interest on the $100. It's almost like I sign a contract, hey, I'm giving you $100, and you continue to earn interest, but only on the 100. Whereas in scenario 2, in the first half of the year, he says, you're earning interest on the 100. But in the second half of the year, you're earning interest on the 103. And so for half of the year, you're earning interest on a higher amount of dollars. Follow? And hence the extra 9 cents. Because 9 cents is in fact half a year's worth of 6% interest on the extra $3, if you think about it, right? Yeah. Okay, so this is amazing, but also troubling. Because what this means is that we should all be going to the bank as often as possible and taking our money out and putting on funny hats and wigs and googly eyes and going back to the bank and opening new accounts. In order to prevent Americans from withdrawing all their money every single day and redepositing, we can solve this problem with math. And the solution to the problem is the mathematical construct known as compound interest. Compound interest simply simulates the process of withdrawing your money and redepositing it. Is this how Giles did it last year?
Yeah.
You didn't tell us story.
Kind of yes, kind of no, kind of whatever. Okay, so what is compound interest? It's that. It's when a bank compounds, they're essentially withdrawing money and then redepositing it again. Okay, so we have now an extra parameter. We have P, the principal, in dollars. We have R, the interest rate. We have T in years. And we have a new thing. This new thing is N. This is the number of times per year that we compound. Okay, well, let's figure it out. Suppose, and in your brain, think of N as maybe 12, right? If N is 12, it means that every month your bank is going to take out the money and redeposit it. Okay, so now let's make a chart, because I don't see any other way to do this. And the chart is going to be our sort of analysis of the amount of money in the bank at a certain time. You keeping me in frame?
Yeah.
Okay. So, all right, how much money do I have at time 0 in my bank account? No, we're moving on to general. We're doing it in general. Is that okay? P.
Oh.
Yeah, so I have P dollars, right? On the day that I deposit my money, there's P dollars in my bank account. Okay. Fast forward. What is the next period of time about which I can be sure how much money there is in my bank account? 1/12, he says, right? Yeah, but I'm doing it in general. So really it's like 1.
N over, T over N.
Oh, this is hard. If I'm compounding n times per year,
T over N.
1 over n.
then 1 over n, right? If I'm compounding n times per year, then the first time I compound is that when 1/n of the year has gone by, right?
Yeah.
So if I'm following this formula, let me check back in with my money after 1/n of the year has gone by. If you prefer to think of it as 1/12 every time I say n, that's fine, that's good, right? That's actually what Winston said, right? After 1/12 of the year has gone by. So now, what does the bank do at this point? The bank takes all your money out and then puts it all back in. Follow? Okay, so how much money should we have? Well, I'm going to have my original principal, and then I'm also going to have what?
R.
The amount of interest earned. How much interest was earned during that 1 month, or that 1/n of a year?
R over N.
Principal times the interest rate, which is R, times the amount of time which has gone by. How much time has gone by? 1 over n. Everyone clear on that?
Yeah.
Okay, so that is the interest earned, that was the original, and thus I'm going to have P times 1 plus R over n is the amount of money I'll have in my bank after 1/n of the year has gone by. Okay, now skip forward. What's the next point at which I can be sure how much money I have? 2/n of a year have gone by. Okay, after 2/n of a year have gone by, how much money should I have? Well, now what's interesting is I'm going to have the amount I had at the beginning of that second month, or second nth, which is P times 1 plus R over n. But I'm also going to have however much interest I earned over that second nth of a year. And now I'm going to be earning interest on that number, right? Because that's the whole point of Your bank took out your money and redeposited it. So I'm going to have my principal is actually P times 1 plus R over n. My interest rate is R, and the time that went by is, oh, careful, 1 over n. Because I'm still just computing the amount of interest earned in that 1 month, right? Since, everyone with me?
Yeah.
Okay, and now, of course, I can factor out a P times 1 plus R over n, and I'm left with 1 plus R over n. Keep me in frame. So what does this turn out to be? P times 1 plus R over n squared. Okay, now I can just keep doing this, right? Let's do 2 more. Check back in at time 3 over n. How much money do I have in my bank account? Well, I'm going to have the amount that I just had at the end of the second month, P times 1 plus R over n squared, plus the interest that I just earned during that nth of a year. And the interest that I earned during that nth of the year is my principal, which is that number, times the interest rate times the amount of time that just went by, which is 1 over n. And again, I can factor out a P times 1 plus R over n squared, and I get P times 1 plus R over n cubed. Okay, this is pretty cool. Also, why is this relevant to what we're doing now? Yeah.
It's like a geometric sequence.
It's a geometric sequence, right? The amount of money that I have in the bank, as long as I only check in at certain month intervals, this is a geometric sequence. Okay, let's skip ahead to n-nths of a year. When n-nths of a year has gone by, otherwise known as 1 year, how much money is in the bank? P times 1 plus R over n to the
N minus 1.
Wait.
N.
N minus 1.
N.
I think it's n, right? Yeah, because after 1/n of a year, I've multiplied by 1 plus R over n once. After 2/n of a year, twice. After n/n of a year, n times. Follow? okay? Because n times have I done this compounding step. Okay, and finally, let's just go to arbitrary t. If t years have gone by, how much money is going to be in my bank account? Answer.
P over N.
P times
1 plus R over N.
1 plus r over n to the...
N.
Now I have to be careful, right? In t years, the question is how many nths of a year have gone by?
And
And the answer is nt, right? If there are n nths of a year each year, and there are t years, and there are nt total nths of a year. Okay, behold thus then the compound interest formula, which is the amount of money I have in the bank at a given time, is the principal times 1 plus r over n to the nt. Okay, this is the thing you do with jobs. All right, and this might be total review for some or all of you. What is important to note about this formula is its very limited applicability. This only applies to the situation, which is not how normal investing works, in which you have a giant chunk of money, you put it all into the bank in one step, and then you never touch it again. You don't withdraw it, you don't add to it, nothing, right? That's what this formula is good for, and that and only that. Okay, in the last 2 minutes, what we will now do is we will consider what happens if you have $1 and you invest it at 100% interest for 1 year. And we will let n, the number of times compounding, be who knows. Okay, so let's set it up. If n is 1, that means you're compounding only 1 time per year. But since we're only investing for 1 year, that pretty much means we're not compounding at all, right? So common sense says if you're making 100% interest and you invest $1 for 1 year, how much do you have at the end of the year? $2. And of course that's borne out by the formula if I want to use formulas, right? It's 1, the principal, $1, times 1 plus the interest rate, which is 1, over n, which is 1, to the 1, n is 1, times t is 1. Okay, so that's just 2 to the 1 time, yeah. So what we get is $2. Okay, cool. What if instead we are going to compound 2 times per year, which really means halfway through the year we're going to compound once. Okay, formula says 1 times 1 plus 1 over 2 to the 2. Follow? So what is that? That's 3/2 squared, which is 225. Okay, cool. If I want to do 4, it's going to be, well, it's just going to be 1 plus 1/4 to the 4th. I don't know how to do that in my head. I think it's like 244 or something. Can someone double check that? Either way, it's getting pretty good. I am starting to get really happy, and I'm starting to have magical cow-based thoughts of riches beyond my wildest dreams. Is it 244? Okay, good. So what now if I want to? What if I want to compound 12 times per year? Do it. That would be 1 plus 1/12 to the 12. What am I going to get? So much money.
2.61.
2.61, that's kind of good, I guess. How about now I want to compound 1 million times per year. So that's 1 plus 1 over 1 million to the 1 million. Now I will have how many dollars?
2.71828.
2.718. I'm not so happy about that. That's less than I thought. It turns out that there is some upper limit, and that upper limit is E. So as n approaches infinity, the expression 1 plus 1 over n to the n approaches this number E. That is our definition of E. Okay, I have several more things to say about this. One, is this basically a review for all of you?
Yes.
Ish? Okay.
Yeah.
I would like to focus on the inherent tension between the parts of this formula. But I will not, because that was the bell. Hit the off button.
But I mean, just